Okay, we're back for the second half of our memory makers for this year. In 7.7, which is about quadrilaterals, we actually have two versions of the same memory maker. Some people prefer one over the other. You hopefully remember this. This is our first memory maker where you have quadrilaterals. And down from that, you have parallelograms and trapezoids. Excuse me. There are other types like kites and that kind of thing. But for 7th grade, these are the primary two types. Parallelograms can be separated into two types. Rectangles and rhombuses are special categories. They're also obviously just parallelograms. There's a special type of rectangle, which is a square. It's also a special type of rhombus, and that's what is shown by this diagram. As you go up the diagram, we would say always. Like a square is always a rectangle, always a parallelogram, always a quadrilateral, also always a rhombus. But as we go down the categories, we say sometimes, but not always. So sometimes a quadrilateral is just a quadrilateral. It has four sides and no other special characteristics. Sometimes it's a parallelogram. So I hope that makes sense. Another option of another way to write this same kind of content is by writing it like this, where we have like a mat that has quadrilaterals. So everything that lays on this mat, they all have four sides. A kite, a trapezoid, but they're special. They have their own set of things, like a trapezoid has exactly one pair of parallel sides. This oval is for parallelograms. A parallelogram is a type of quadrilateral. You can see it sits on that mat. A rectangle is a special type of parallelogram. It sits on that mat. A rhombus is another special type of parallelogram, but you can see that rectangles and rhombuses are not the same. A square has all of the characteristics of rectangle, of rhombuses, of parallelograms, and quadrilaterals, and you can see it if you look at that mat. I'm going to let you see that since it was trying to focus several times while I was moving that pen. Remember that you can stop this video at any time and back it up if you need more practice or to see it again. The next thing that we're going to talk about is transformations. There's actually a whole lot more than 3 here, but we're going to start with translation. Remember that a translation we write with capital S and L because that reminds us that this is just a slide. If it's vertical, it means it's up or down. Up is positive, down is negative. If it's horizontal, that's left to right. Left is negative, right is positive. The next one is a reflection. Remember we capitalize FL to remind us to flip. Now here are the deals with how to flip. If it's over the x-axis, you keep the x and change the y. If it's over the y-axis, you keep the y and change the x. If it's over the x, you keep the x. If it's over the y, you keep the y. Otherwise, you change the other sign of the other coordinate. For a rotation, remember that it has 2 T's. One quadrant would be 90 degree. 2 quadrants is 180 degree rotation. That T means to turn and turn again if you have it 180. For a 90 degree rotation, you switch the coordinates places. The x becomes the y becomes the x. And you take the sign of the quadrant that it will be moving to. If it's 180 degrees, you keep the coordinates exactly as they were, but both of their signs change. 90 degrees, switch their coordinates, sign of the quad. 180, keep the coordinates, and both signs change. Down here, if I can get to it, you can see clockwise means to go this way, and counterclockwise means to go this way. Like a clock goes clockwise, or opposite how the clock goes, that's counterclockwise. Dilation. Remember that that's the two eyes like you have at the eye doctor. It can make things bigger, like what normally happens at eye doctors, or it can make things very small. You multiply all the numbers by the scale factor in order for a dilation to occur. The next one, 7/9 and 7/10, that's probability. Remember that or means to add, and then means to multiply the different fractions. Remember theoretical versus experimental? Theoretical is what I think would happen based on how many outcomes are possible and how many ways to get that. Like the probability of getting heads is 1 out of 2, no matter how many times you flip that coin, theoretically. Experimental means you did it. You do something and you make a chart and you decide how many out of that based on the experimental data. The formula for probability, is if it's the probability of whatever, it's how many ways can you get that whatever over the total number of outcomes or how many times you tried. The next one is 7/11. That's histograms and other graphs. Remember that in histograms, those bars touch. They're talking about intervals, not a specific number. So you can't really know exactly how many had 12 because it's within a range if it's talking about a histogram. In terms of the other graphs, I'm going to have you go back for just a second and look at that other side when we talked about this, the percent over 100 equals part over the whole. You may end up using that kind of proportion again or something similar for that. This is on 7476. That should be a hint to you to go back and look at that if you need to. For 7/12, the first thing, and this is going to help you as we look at 7/8 with transformations as well. X is the first value in an ordered pair. It tells you how far you're going to go left or right. Left is negative, right is positive. The Y value tells you how far you're going to go up and down vertically. Up is positive, down is negative. Remember that right in the middle of a coordinate plane, that place is called the origin. Its address is 0, 0. And around that origin, you have these numbered quadrants, 1, 2, 3, and 4. And you can see that it tells you what kind of points are in there. Plus, 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 negative, 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 positive, negative. I think most of you have that, but boy, that's a great thing to remember. And I'm going to pause right there and let you make sure to have that copied. Again, you can always ask to pause the video as well. On 7/13, these are to write expressions and equations and inequalities, I guess, from phrases and sentences. You have one thing that I've encouraged you to do, and that is to write in order as best you can, from the words to numbers and numbers to words. So if they're giving you a word problem, you want to, as much as possible, write them in the order that they're given. And then watch out. The only difference to this usually is if you have one of these 3 words: than, from, or to. Those are our flipping words. So if you have than, from, or to, whatever number would normally come at the afterwards, you move it to the front. But it has to have one of these 3 words in order to do that. Again, remember to pause this video if you need more time. For 7.14 and 7.15, these are solving equations and inequalities. So the first thing I want you to do is I want you to write down that you do the opposite operation with exactly the same number, the same exact number, and you do it to both sides. I am hoping that you remember that's how we solve equations and inequalities. You do the same thing for both types. Do the opposite operation with the same exact number to both sides to get the variable by itself. That's your whole goal. If you have a two-step, you probably want to get rid of that adding or subtracting first before you get to the multiplying and dividing. If it's an inequality and you're graphing it, remember one, that the inequalities, they show actually a whole range of answers. An infinite number of answers, actually. If it's an open circle, that would be greater than or less than. It means that that number is not a possible solution, but everything to the left or right of it would be. If it's a football player, remember we put the eye black, that would be greater than or equal to or less than or equal to. You have a filled in dot. That means that that number is an answer possibility, as well as everything to the left or right of it, depending on which way we're going. Remember that in order to decide which one of these you use, you actually have to ask yourself, what would be an X that could fit in here? Especially if it's written on the other side, like the variable is on the right and not on the left. If you are solving an inequality and you have to end up multiplying or dividing by a negative number, you have to flip that sign. Less than becomes greater than, and greater than becomes less than. But that's only if you are multiplying or dividing by a negative number to solve it. This is when you're solving it. Now you have to know all of the properties in the next section, which is 716. You have to know all of those properties, but I'm going to give you a few ways to remember some of the most frequently used ones on tests. Remember about commutative property, that we underline that CO, and hopefully you're thinking in your head CO. That means that the numbers change order. That's what that CO stands for. Commutative property, numbers change order. Make sure that you're paying real close attention if it's multiplying or adding, though, because it could be for either. Another property that we did the same kind of thing for was the associative property. And remember that we underlined the SO, because that means, in this case, the numbers are in the same order, but the parentheses move. The numbers are in the same order, but the parentheses move. Associative, SO, orders are in the same order, but the parentheses move. The last one that I'm going to put on here for us is the distributive property. That's when you have the TVs going to the individual stores. Remember, we got the TV on the outside. Here are the stores inside. You're distributing that 3 to the stores, and that would be like 3 times X plus, because that's what's in the middle here is the plus 3 times 2. Please make sure that you're going through and that you are copying all of these. These will be a part of your notebook check at our next notebook check time.